Okay, so we're going to do 13.4 today, adding and subtracting polynomials. And I'm sorry if you can't hear me, my voice is kind of going out. But on Wednesday we looked at combining like terms. Excuse me. And adding actually does look like combining like terms. So whenever we're adding, it will look a lot like combining like terms. One thing that we do a little bit differently is we're going to stack the like terms. It's not as important whenever you're adding, but it's very helpful whenever you're subtracting. This is also helpful whenever we came up with, we looked at missing terms on Wednesday. So for this first one, we have a 3x squared, a 2x, and a 2. And this one we have an x cubed, an x squared, an x, and a 4. So what we want to do is we want to make sure that we stack the like terms. So this 3x squared is going to go with this negative 2x squared. So I can write the 3x squared underneath, and then minus 2x and plus 2. And then I can just combine my like terms. So I have my 5x cubed plus x squared, because negative 2 plus 3 is a positive 1. And then plus x, again, same thing, positive 3 minus 2, and then minus 2. So that's adding. Like I said, it looks just like combining like terms. One thing for this section that they want you to do is be able to apply adding polynomials. So we're going to look at it with finding perimeter. And perimeter just means to add up all the sides. In case you've forgotten that. Perimeter add all sides. So if I'm looking at this triangle, I'm going to look for my like terms. So I see here that I have a 9x to the 5th, and I have another x to the 5th term here, and that's it. So I have 9x to the 5th plus 5x to the 5th, so that's going to give me 14x to the 5th. I also have some x squared terms. So I have a 6x squared and a 7x squared. So that gives me 13x squared. And then I also have this 3x to the 6th, but it doesn't have any friends. So I'm going to put this one out front. 3x to the 6th plus 14x. And then I have this plus 3. Again, doesn't have any friends. So my perimeter then would be 3x to the 6th plus 14x to the 5th plus 13x squared plus 3. So it's just combining like terms. Subtracting is a little bit different because we need to know what the additive inverse is. It just means multiplying a polynomial by -1 or finding its opposite. So if we're looking at this example, we want the opposite of negative t cubed minus 6t squared plus t plus 4. So we're just going to change all the signs and everything in the parentheses. So it becomes a positive t cubed positive 6t squared minus t minus 4. And it's important that we know how to do this because when we subtract, that's what's going to happen with the second polynomial. So when I have 9x to the 5th plus x cubed minus 2x minus all of this, I have to change all of these signs. And I'm going to stack them underneath again just so I have my like terms. So this becomes positive 2x to the 5th let's try that again. 2x to the 5th, and then a minus 5x cubed, and then plus 6. So I left the empty space there just because I didn't have any x's to line up there. So then I'm going to add my like terms, and I get 11x to the 5th minus 4x cubed minus 2x, didn't have anything to subtract from it, and plus 6. So subtracting means you have to change change the sign of the second polynomial and then add. Okay, so let's look at a couple more examples. So number 6 over here, it has it already stacked like I was saying. So you're going to stack your like terms, and you can see when they leave the empty spaces, that just means there wasn't a like term to match with. So when I go to add, I just carry down this 7x to the 5th. Same thing with the 8x to the 4th. There's nothing to add to it. Same thing with the negative 10x cubed. But now with my x squared, I can add, and I'm going to get plus 3x squared. I don't have anything to go with my x, so I keep my minus x, and then plus 5. So it's just combining like terms, nothing to it. Just make sure you know how to add your fractions. Find common denominators if you don't already have them. Just remember to match up your like terms. So make sure you're matching the exponents correctly. So here again is the opposites. So opposites just means you're going to change the sign of everything in the parentheses. So this becomes negative 7x cubed minus 3x plus 2. Same thing over here. This would be positive a to the 6th plus 8a cubed minus 2a. Just changing the signs. Okay, so for the subtraction, remember the biggest, most important part is to change all the signs of the second polynomial. So if I'm going to stack underneath here, this would say minus 6. I'm going to make sure I match them up, plus 2b and minus 9b squared. Notice I matched up the exponents so that I have my like terms. So this would give me negative 1 plus 3b squared. And then these two would subtract out. There gives you a negative 2 plus 2 gives me a 0, so I don't have to worry about putting anything else. Let's look at this one. It's already stacked, but I still have to go through and change all of my signs. So just remember, this is a negative 5x squared minus x squared plus 17x plus 4. Now we can, since they're already stacked with their like terms, you can just add. So that gives you 3x cubed minus 4x squared plus 6x minus 2. So just make sure you change the signs of your second one and then combine your like terms. So this one asks you to find the perimeter for the polynomial. Again, you just want to make sure that you find all your like terms. So I have 6x, a 4x, a 2x, a 3x, and a 4x. So I want to make sure I add all of those together. So that gives me 10, 15, so I have 19x. And then add your other like terms. So I have 5, 10, 15, and the 4 and the 6, so that gives me plus 25. And that's my perimeter. I don't have to do anything else. I can't add any more. These are not like terms, so just leave my perimeter like that. this represents some number. We just don't know exactly what that number is. So this one says to find the polynomial for the shaded area. So that means we need to find the area of the big circle and the area of the little circle and then subtract them. So area of a circle is pi times the radius squared. So for the big circle, our area would be pi times y squared, because my radius is that line. Then for the small triangle, it would be pi times 2 squared. So we can rewrite this as a polynomial showing the shaded area as pi y squared minus 4 pi. And that's the polynomial for the shaded area. So we would have to subtract to get the shaded part. If you have any questions, just let me know. It's pretty easy though.